Hello everyone, welcome back again to acids and alkalis. We have talked about what acids and alkalis are and where are they found and what are the main properties of each and where are they on the pH scale. We said as we go away from 7 towards the 0, we have more acidic substances, and as we go away from 7 to 14, we have more alkaline. At 7 exactly, the substance is neutral. We said as we have more OH or hydroxide ions, as we have more concentrated alkali, as we have more H or hydrogen ions, we have more concentrated acid. By looking at this when an acid reacts with alkali, in order to be familiar why we use alkali in detergents or in soaps and so on, in order to neutralize or to cancel out the acid which is found in grease. The dirt and the grease actually are made up of acid substances. So a very familiar example, which is called neutralization reaction, takes place. A neutralization reaction is a reaction between an acid and alkali to produce neutral substances. That's why the name of a neutralization comes from. In order to produce neutral substances, which are salt and water, both water and salt are neutral substances. Okay, if you want to talk about how this reaction happens, let's have this reaction. Here we have NaOH, which is sodium hydroxide. Sodium hydroxide, it may corrode your skin away if it is so concentrated. It is a strong alkali, sodium hydroxide. So any alkaline produces hydroxide ion. Okay, so we see the OH ions here. We make it into ions that, we split it into ions that make it up. NaOH, Na, which is sodium ions plus, and OH, which is hydroxide ion minus. Now, HCl the same. We make it into the ions that make it up. We split it. H, hydrogen plus, since it is an acid, releases hydrogen, and Cl, which is a chloride ion. Now, positive ions reacts with negative ones and so on. The positive ion from the alkali, which is Na, positive. So it goes with the negative one, Cl minus, as we see here. Na reacts with Cl minus. So what is left here? OH hydroxide ion and hydrogen ions are left. So the OH here reacts with hydrogen H plus there in the acid, as we see. So both produce OH. When they react, they produce what? Water. They produce water. So water is a neutral substance. Yes, here it is. NaCl, they produce what? The salt, which is sodium chloride. No need to know the symbol formula or the symbol equation for the reaction. Just I made it simple in order to show you how to find out the products from neutralization. Just to know, whenever we have sodium hydroxide in words reacting with hydrochloric acid, producing sodium chloride, which is the salt, and water. Both substances are neutral. That's why this is called a neutralization reaction. Thank you. Now, let's go and react other acids, such as nitric acid and sulfuric acid. Again, no need to know the simple equations, just to know the word equations. Here we have potassium hydroxide. Potassium hydroxide is a strong alkali reacting with nitric acid, as you see. Here we take the OH from hydroxide with H from nitric. So hydrogen ion from the acid and hydroxide ion from the alkali. Releasing what? Water. Making what? Water. Okay. Now, what is left? The other ions. Potassium ion is left with nitrate from nitric to produce potassium nitrate, which is the salt. Again, let's do it for sulfuric acid. As we know, sulfuric, we split it into hydrogen ions and sulfate ions. So if you want to work it out, it would be like the following. OH from hydroxide, H from sulfuric here. We take it to produce water, while sodium reacts with sulfate to produce sodium sulfate as the following. So, the main principle is to make the compounds into ions. It's easier than to recombine the ions together, producing new products. It's very important to know salt, water, and neutral substances that are produced by neutralization reaction from the reaction of an acid with an alkali. Acid and alkali reaction is very important in our life. Next time we are going to talk about using of a neutralization reaction in our life. Thank you.